Now we're going to be looking at gravity, which we said is due to the change in the density of the ether. So let's dig into this. In the 1960s, telescopes suggested that each galaxy in our universe had a concentration of black holes. And apparently, there was a massive concentration in the center of each galaxy. And it was in the order of you'd measure the concentration in terms of millions of suns if we took our sun as the average mass of one of these black holes. It was millions of them, tens of millions, and today we've even discovered things with hundreds of millions. So this gravity here gets incredibly distorted with these black holes because light itself can't come out of it. And yet this has everything to do with holding our galaxies together. They're at the center of every galaxy. There's also apparently a lot of black holes that are scattered throughout our universe, throughout the star, between the stars, and many of them are quite small, microscopic in size. And the interrelationship of the ether and the gravity is really an embryonic field that is just starting to get going. But this is going to allow for the possibility of creating anti-gravity. And if you create anti-gravity, then you can create cars that don't have any wheels and other things. But the point is that gravity creates all kinds of patterns. We talked about black holes. Without the black holes, even, there's patterns of galaxies. We see spirals, we see clusters of galaxies, we see walls of galaxies when you step back and look on a big enough scale. So gravity is an amazing entity that has interactions over huge distances in shaping what our universe is. The thing about gravity with this ether is it has this quantum foam. John Wheeler, who was at Princeton in 1955, talked about a quantum foam or the foam of space-time, the ether, that describes this idea at this incredibly small Planck scale, which is, like as I said, 15 orders of magnitude smaller than that of a nucleus. So space itself, when you get down there, is not smooth. It's turbulent, it's foamy. There's all kinds of energy fluctuations that occur, and on and on. But gravity's role in this, it's not just a force acting on space, it's a manifestation of the geometry of the foam and the warping and fluctuations of this foam at tiny scales, or what we perceive as gravity, at larger scales. And this could very well be what it is. We don't know, but this is our current working hypothesis. They're virtual particles. They're temporary fluctuations that occur. And they create tiny gravitational fields that warp space-time and contribute to the overall weight and the curvature of the universe. And there you have it. So gravity is also viewed by many as what's called an emergent property. Is gravity really a fundamental force at all, or does it emerge from these deeper quantum interactions? That is, with the change in density in the ether, is that really what makes gravity emerge? So one approach is to deal with entropy or so-called entropic gravity. And here, gravity is the result of the rearrangement of information at a quantum level. So the push of the quantum interactions mimics gravitational attraction. That's one approach. Another one is a holographic foam. So some models are linking the quantum foam to dark energy, insisting that the collective energy of the microscopic fluctuations is what drives the expansion of the universe. Again, no data to back these things up, but interesting and very thought-provoking. So there you have it.